Okay, well, welcome everybody to this meeting of the virtual CICS user group. I'm Trevor Eddles. I'm CEO of iTech Limited. We're a mainframe consultancy, analysis and technical authoring organisation. We're the people responsible for the content on the virtual CICS website, and we produce the newsletter. And if you haven't been on the website, it can be found at virtualcics.hostbridge.com. And if you've got friends who use IMS, we also look after the virtual IMS user group. Okay, let's start by running through the agenda for this meeting. As usual, most of the meeting will be taken up with a presentation, and today our guest presenter is Colin Penfold. He's technical leader for IBM CICS Transaction Server Security, and he's going to be talking about what's new in CICS security. A copy of the slides from his presentation will be on the website later today, and if you missed any of our previous meetings, you can download copies of those presentations from our website. You can also listen again to the whole presentation. There's links on our resources page of the user group website. So that's virtualcics.hostbridge.com/resources.htm. Following Colin's presentation and any questions you have for him, we'll move on to the latest CICS news and latest CICS related articles. Feedback request is there to remind me to ask you for your feedback about this virtual meeting, and then I'll give you the dates and times for the next couple of virtual meetings. So that's the plan for this meeting. I'm anticipating that it'll last around an hour. Anyway, as I just said, today's presentation is from Colin Penfold. Colin has been at IBM for almost 40 years, the last 30 in CICS. He's designed a number of features in CICS, including channels and containers, the Link 3270 bridge, and CICS's support for the IBM Health Checker for ZOS. For the last decade, he's been the technical leader of CICS security, during which time he's designed security features in CICS, including TLS enhancements, distributed identity support, and several new authentication mechanisms, including MFA. So, Colin, I'd like to thank you very much for being with us today. And let me stop sharing, and you can start sharing your screen. But first, before I do that, let me admit the last few people joining our meeting. Stop share. Right, so Colin, you should be able to share your presentation now.
Okay, you can see that, I hope.
Which we can, yes.
Okay, so I'll start. Thanks very much for that introduction, Trevor. Yes, I'm going to talk about what's new in CICS security. And what I'll be covering is what's new in CICS TS 5.6, so some new security features in CICS 5.6, and also in the CICS TS Open Beta. Some of you may have noticed on Friday, I think it was, the latest update on the CICS TS Open Beta with a lot of new features for you. So my presentation is going to cover a number of topics in security. There'll be enhancements to TLS, then some information about what we're doing in documentation and best practices with the health checker. I'll follow that by some changes to and enhancements to monitoring and stats, and a new feature called instruction execution protection for preventing threats. And finally, I'll round off with some simplification work we're doing to make your diagnosis a lot easier, we hope. So first of all, the enhancements to TLS, and I'm going to cover three things in here. First of all, SNI support, then TLS 1.3, and also replacing outbound default ciphers. You will see in each of these introduction sections that I've got, there's a little mark to indicate whether something is in the open beta. If not, it's available in 5.6 or possibly earlier via APAR. So firstly, I'm going to talk about SNI. SNI stands for Server Name Indication. SNI has been around in its current form for about a decade, but has become very popular lately due to the increased use of virtual hosting on cloud services. And CICS has implemented client support for SNI so that CICS can connect securely to SNI-based virtual servers. And this function was introduced in APAR PH 200.63 and was backported to 5.3 because of a number of requirements we've had in this area. Now, in case you're not familiar with SNI, here are sort of a couple of slides describing what it's about. Firstly, without SNI, CICS is attempting to connect to two virtual hosts on a server, so host A and B on this server. The URI maps identify the host names and ports, and a DNS identifies the server. Both requests are seen as requests to the server rather than the virtual hosts, and so the server certificate in green is returned. This prevents CICS from securely identifying the virtual hosts A and B. With SNI, CICS passes additional information in the handshake with the virtual host name. This allows an SNI-enabled server to return the certificate for the virtual host and enables CICS to securely identify the correct host. Now, all this is done without the need for any configuration changes. By just changing some information in the information that we transmit, we work with any host that is which supports the SNI protocol. We don't require the host to support an SNI protocol, so it won't break any existing work that you're doing. A major change that we've made in the open beta is we now support TLS 1.3. TLS is the first major change to TLS since 2006, and it is a very major change. The ciphers are simplified, for example, from 37 ciphers in TLS 1.2 to 6 new, very strong ciphers in TLS 1.3. 3 of these are supported by ZOS and also hardware. There are performance implications and also, of course, security changes as part of this change. An important security change is there is now a single handshake which encrypts more of the information in the handshake. There's also stronger security algorithms supported by the new 1.3, which is important and will be important in the future, especially as we go into the quantum era of computing. And there's also changes to caching. So CICS was a very early adopter of SSL, and as a consequence of this, it developed a few legacy features which proved a little troublesome to migrate from. We normally endeavour to be backward compatible, but occasionally this is no longer possible, or in some cases of security options no longer desirable. We try and make the path as smooth as possible if upgrades are required. We're introducing a new SIT option called max TLS level, so that you can now control in a simple way the minimum and the maximum TLS protocol supported on a region. With this change in the open beta, the TLS 1.0 protocol has been withdrawn because it's no longer something that any auditor would really allow on a system. Also, there was a SIT parameter called encryption, which basically set the TLS protocol level to 1.0 and the maximum TLS level to 1.1. This is a highly confusing method of setting those parameters, so that's replaced by the min TLS level and the max TLS level parameters. Another major change to the configuration is the deprecation of allowing numeric ciphers to be explicitly specified on the resource. As many of you will know, the RDO definitions have got numeric ciphers on them. That worked fine 20 years ago when there were a few 2-digit ciphers. It no longer works in the era of these 4-digit ciphers. And so back in 5.2, we introduced XML cipher files to put your ciphers in. This was an easier way of configuring things because if you needed to make a change, they're all in just one XML file. But with the new 1.3 level, we're going to have to deprecate these ciphers, the numeric ciphers. Currently, we have a set of default ciphers when you define a new resource which requires ciphers. You will see that series of 2-digit numbers pop up on the ciphers option. That's now going to be replaced by a file called default ciphers, which is in the HFS system. We provide a copy of that in the which you copy into the USS config directory and make any changes that are necessary for your company. Clearly, there's obviously a migration activity for customers who haven't already converted to cipher files. Therefore, to ensure that an upgrade to TLS Open Beta won't break anything, the maximum TLS level defaults to 1.2 rather than our traditional defaulting to the highest level, so that it doesn't break those of you that are using numeric ciphers. We've got a clear migration path that's documented in the Knowledge Center, but I'll give you a few bits of information from that. You'll see on the left numeric ciphers there, which are on an old resource definition. If you try and modify one of these resource definitions, you'll get this warning saying that the ciphers attribute containing numeric codes is deprecated. If you blank out those ciphers, instead of the numeric ciphers appearing, you will now get the XML file default ciphers appearing with inside it the ciphers that you've selected. If you upgrade, when you upgrade to TLS level 1.3, the numeric ciphers are no longer supported. There are no 2-digit ciphers that work with TLS 1.3. So all definitions must use XML files that contain at least one TLS 1.3 cipher in it. If you try and install a 1.2 cipher, the numeric ciphers, the installation will fail. Another problem that the change to TLS 1.3 produces is with the web open command, in which you could specify ciphers. We've said for many years that you should really use a URI map rather than specifying in the application program the ciphers that you're going to use. With a max level of TLS 1.2, we'll continue to support these 2-digit ciphers, but if you try and translate using the new version of the translator on the Open Beta, it will fail and you'll have to change to using the URI map. If you use exist code which was compiled under previous releases, we'll still support it, but we'll issue warning messages once per program that issues the command. So you can find all of the programs that had got the web open in them. But the requests will still be honored. With Max TLS 1.3, we can no longer support the ciphers option because it only supports 2-digit ciphers. And therefore we will ignore it, put out a warning message to indicate it's been ignored, and use the default ciphers from the XML file. So migration to 1.3, nothing to do with CICS, it's just the nature of the 1.3 TLS level. It is a little bit more of an upgrade than we've been used to. In the past, when we've migrated to 1.0, 1.1 and 1.2, there've been no need for any changes. It's been a fairly smooth upgrade. But 1.3 is going to be a little bit more of an upgrade. However, it is worth it in the end on the grounds that we do need to use the XML ciphers to make sure you're up to date with the strongest ciphers, and it will make things easier in the future because removing ciphers which have been hacked will be a much simpler exercise than having to change 1,000 resource definitions, for example, or changing application programs which specified those ciphers. Finally, for TLS, we received an RFE in from a customer fairly recently because of audit problems with an auditor that they were raising about the default set of ciphers. As I said earlier, the default 2-digit ciphers, which have been there since we introduced TLS, are fairly weak now, and for the audit requirements, they were not sufficient. And the customer didn't want to make changes to all of their programs which used WebOpen without a URI map, which would then use the default ciphers. So what we provided for them, and this is on 5.6, is an APAR, which has just been released this week, which has default ciphers used in place of the default ciphers XML, the ciphers in that, used in place of the default ciphers on the web request and also on the invoke service requests. Because this is obviously a change in behavior, as with all of our D-type APARs, all of our new support that we introduced in CD, we feature toggle this as disabled by default, and you enable it by the feature toggle that's mentioned there. So now on to the next section, two related topics. One are changes to the CICS security documentation, and also related to that are health checks, new health checks on the ZOS Health Checker. Both of these are in the open beta. Now, the average age of a system programmer has been decreasing recently. Not through some magic elixir of youth, but due to a welcome influx of new graduates replacing the system programmers as they retire. And we've seen quite a lot of these new system programmers. Now, the 500 pages of security documentation that we've got has been built up over 50 years. And whilst it's a good reference for those folks who have grown up for it, we found that it's not easily consumable by the newer graduates. The language of computing over 50 years has changed, and in particular, security has changed quite significantly, making it quite difficult for new joiners to understand some of the terminology. Also, the way of consuming information has changed since the days when documentation was measured by how many feet of manuals you had on your bookshelves. We're therefore reworking the security sections of the IBM docs to add education and a scenario-based structure with clear advice on best practices and recommendations. And this is probably best demonstrated by showing you what the new documentation will look like. So you can, I've got a link at the end of the presentation to the new documentation site for the open beta. Normally, we don't say what's coming up in the future, but I think this gives it away quite clearly because there are two sections in the IBM docs. One saying new doc and one saying previous doc. And through the open betas that we've been doing, information has been moving from one place to another. So I think that gives you a pattern of what's actually happening here. What we've got is a whole series of sections, which are education sections about the concepts in CICS security. And that on the top left is not quite up to date. Just before the open beta was released, I added a section on how it works, confidentiality and integrity. So you've got a whole series of sections about how it works, which are the education sections on what security means, trying to use industry terms where possible, but also mentioning the historic CICS terms. We then have a series of capabilities, and we've been working very much with the Montpellier site, who work a lot with customers, to look for the key scenarios that customers use and are trying to describe those scenarios as part of the capabilities. So each capability, like for example, this IPIC section, will have a how IPIC security works, and then a section on designing with various scenarios, design examples, as I call them there. And then after that, there will be configuration sections which match the design examples, telling you specifically on a task basis what you have to do to configure that design example. And all of these examples that we've got will be implemented within the Hersley Bank test setup that we have in Hersley. So the way that we're doing this documentation, you will see, is quite unrecognizable from the previous documentation. But we appreciate that you've got a lot of bookmarks around for various bits and pieces. So the old bookmarks will still work, and we will redirect you to the new pages in the new structure. So here's an example in a little bit more detail of what one of those design examples will look like. We're trying to get a consistent way of describing all of these. So there'll be eventually a consistent diagram describing various information about a scenario, an example. It will show you things like what user IDs flow on the system, what are the RACF profiles and permissions, what security resource definitions are required for setting up this. And accompanied with the diagram, you've got the numbered flow going across there, and that will be accompanied by a list of what is going on, a step-by-step guide to what's going on in how this scenario is designed. So it shows the numbered flow of what happens with security. And as I say, related to that, the configuration will give you the details of all the security and resource parameters that you need to set up this scenario, including going through what the prerequisite steps and what education you would need to understand this scenario, and what are your potential follow-on steps after you've configured the scenario. The other part of the change that we're making to the documentation is recommendations and best practice. IBM in the past has veered away from putting recommendations and best practice in documentation, but we realize this is not really the right thing to do. We want to try and give you the best advice, but we're now being really explicit on what we mean by a recommendation and a best practice. So a recommendation is just sort of advice that we've seen on many customer systems, or that we know ourselves is the best way to implement something. It's not a mandatory thing. It's not about compliance. It's just that we recommend that, as we've got an example here, a method of protecting your system. Best practices has got a slightly stronger meaning in that it's a recommendation, but we will also validate it using the IBM Health Checker for ZOS, one of the CICS checks on the IBM Health Checker for ZOS. So that leads me on to the Health Checker. Now, I suppose not everybody is that familiar with the Health Checker, because in researching with customers for the work that we've been doing in the CICS Open Beta, we found that quite a few of the SysPogs that we've been talking to aren't fully aware of the Health Check. I've heard of it, but not actually seen it in action. It's been there since ZOS 1.7 and on by default for 2.1. And what it's there for is to design best practice in configuration of the various ZOS components. As well as messages that it produces, there's a nice simple interface in SDSF, which I'll show you. These are a few of the 150 or so checks that you'll see in the Health Checker. And as you can see, each of these checks has got a name and it's got a component owner. So you've got a lot of RACF, you've got some components of JES, and there are many other components, including CICS. If one of these checks fails, there are 3 levels of importance for the failure, and auditors are often interested in these, especially the medium and high failures. If you click on select one of the health checks and obviously have permission to look at it, you will see more information. So I'm going to show you what happens if you type an S and press enter against the RACF certificate expiration. This is quite a useful health check because it tells you when certificates are about to expire or have expired. It only obviously tells you about ones that are known to RACF, but that can be quite important because you get some certain certificates, server certificates in RACF. If they expire, that can take your region down. Now, what you see here is our test system, which has got a lot of very old certificates that we haven't cleaned up, but are useful for demonstration purposes. Hopefully, your VACF database won't have certificates quite as old as that, and they would have been deleted. And so mostly what it will tell you is certificates that are about to expire. So that's what's there for VACF, but what about CICS? We introduced health checks into CICS in version 5, specifically to address a problem identified by a pen test tool, which could cause problems on a poorly configured system. What it was looking out for was if the default user ID had access to critical resources such as CEDA and KEKI, and also the system was able to submit JCL. If that was the case, then it was possible to submit JCL under the region user ID with all the bad effects that could potentially have from somebody who isn't authorized to use the system. Now, this was bad enough on an internal systems, but a port scan identified the odd external system where this applied to by the hacker. So we instantly put up a security alert and put in the health checks so as to alert people about the poorly configured systems. We've introduced into the open beta some new health checks. And these health checks are based upon various reviews that we've had with customers. And they can cover the security of resource definitions, CICS resources, and even the ZFS security. And the idea is to give information about what we would recommend on a production or a production like region. And examples of the sorts of checks that you've got on there is ones that I'm sure you'll all agree having security switched on is quite useful to have on a production system, along with transaction security at least, surrogate security. You shouldn't be able to access with a default user sensitive transactions, and universal access of your HFS profiles is not really desirable. We appreciate though that it may not be applicable for all of the regions you've got, because if you've got LPARs which have got test regions on, you may have different security requirements on there. So this is mainly aimed at the production regions. So here you can see an example of the new checks in the CICS Open Beta. They're highlighted in red, but they will appear blue on the real system. This is just to identify what they are. So there are various things to do with the resources, the region configuration, and also USS security. An example of the sort of thing that you get if you select those is information about with messages to indicate where the system is not conforming to best practice. And again, they've got exception warning and information levels. So we've got here examples of a poorly configured region, deliberately in this case, where Xtran was set to no, so no transaction security, and also a slightly lower one, which says the minimum TLS level is lower than 1.0. Associated with that, if you look up those messages, you'll get advice on what that's, more details about what that message means, and further down, you'll get information about what you should do to mediate that. So that's all the information that got there about the documentation and the health checker. Next section is about monitoring and stats, and also a section about preventing threats. So the first section I've got is something on the TLS protocol. When you're trying to upgrade from one level of TLS to the next one of the difficulties you've got is obviously you don't want to break anything. And so it's important to know if something is using the old protocol, you find that out and fix that client or server that the CICS is talking to before you just make the change to the SIP parameter. So the question is, how do you do that in an easy way? We've had requirements in, quite a number of requirements from customers, or quite a lot of votes on could we please put this information into the monitoring record? Now, there are two cases for this, for the TLS level. One is for inbound requests. So where you've got an inbound request, we will monitor the TLS level, and it's just right next to the information that we already monitor about the cipher that is used, that we put in a few releases ago. So we introduced that for the inbound record, but also as CICS can act as a client as well, you'll also want to see that in the monitoring as well. We can't put that in the performance record because the performance record can only accommodate one inbound request, and you may have multiple outbound requests, an indeterminate number. So we put this in the outbound resource records. So you've got there both the ciphers and the TLS levels, and you can see on here that the transaction that we were using here as a test had got two outbound connections, one of which was connecting to a server which only supported TLS 1.2, and the other server supported TLS 1.3. So that's some new monitoring information for TLS, but there's other monitoring information that we put into CICS 5.6, monitoring and stats. In the sort of pre-web days, when the security domain was created, there were many fewer ways to access CICS. It was mostly sort of 3270. And the only method of authentication was either passwords or pass tickets. And all these mechanisms were very fast and synchronous and ran on a single TCP, the ROTCP. But advances in security have meant that there are many more ways to authenticate. And some of these are asynchronous, some more CPU intensive, and so require multiple TCBs. So this can lead to additional concerns for which customers have requested that we provide some additional monitoring and stats so they can have a look at this. So what we've got here in the stats report is information that we've added to the user domain and also the security domain. There were no security domain stats prior to 5.6 because it just wasn't felt necessary at that stage. So what we've got to start with here is some information in the user domain for the number of ENF events that one gets. Now, this is all about an option that was introduced in 4.2 in CICS, where CICS could listen to RACF if a change was made to RACF to add somebody to a group or remove somebody from a group, or alternatively, if somebody was revoked. We'll listen out for changes to the security, and rather than, as in previous releases to 4.2, you having to wait for for the user delay timeout to expire before an ACE, a security ACE was deleted, we would make it stale immediately. And so you've got information there on the number of ENF events that are received. Not all ENF events relate to user IDs that are known by the CICS region, so we indicate how much noise there is received in ENF events. And we also indicate how many ACEs, how many user tokens were deleted as a result of sign-off, and how many were deleted as a result of an ENF event. In addition, what we've got here in the security is we indicate the number of ACEs on the system. ACEs are 24-bit storage, and so can occupy quite a large chunk of your 24-bit memory. And what you don't want to do is to get too close to running out of 24-bit memory. There was new information in 5.6, which is short on storage mechanism for MVS, short 24 and 31-bit memory. So what you've got here is the number of ACEs that are in use and the number of, with the usual sort of stats of current and peak values. We also indicate the number with things called ICRXs associated with that, and ICRXs are distributed identity tokens. And so if you're using distributed identity, you will see a numbers in that section as well. In addition, we give information on authentications. The authentication information gives you success and failure information, a sort of a summary of how many failures there have been, which can be quite useful if you're looking to see whether whether there is an attack. Obviously, the main place to look through that is RACF and ZSecure and QRadar. There's also information about the number of successful and failed authorization attempts on the system for the various type of resources and types of security within CICS. So there's quite a lot of useful new information in security in the stats. Final part on here at the bottom is the number of parallel security requests. As I mentioned earlier, CICS used to run on the ROTCB, but with the new password mechanisms that you've got, KFDAS and also MFA and various other things, we've had to enhance the way that we do the security. So we run it on open TCBs. This also avoids any thread safe problems. You can easily switch. You don't need to switch to the ROTCB to execute a security request. But there can be some problems if there is a delay in the external security manager. If it's got a lock and is temporarily blocked on a request, what you don't want to do is for CICS to keep on sending security requests to it and block up things. And if we keep on sending security requests to a temporarily stalled ESM, it will bring down the region. So we limit the number of parallel security requests to a third of max task. And this information is reporting the maximum number of security requests that there are in parallel, waiting for a response from the security manager. Finally, for the security monitoring, we've got information here about the time that the security requests take. As I say, in the past, you just had the verify password and the sign-on requests. The verify password was generally very fast in the past, but is now potentially slower because of password phrases in the new KFDAS mechanism, and also for multi-factor authentication, where you're going out to an outbound server to do the authentication. So we record the time in the monitoring record. And there's also a new command called verify token, which is analogous to the verify password and phrase commands, but it's a generalized thing. So it can use, it was introduced for Kerberos tokens, but any new tokens that we introduce, we will use this verify token mechanism. So also introduced in 5.6, I'm not covering it in this presentation, we supported RACF JWT tokens, and it will give you some information if we're verifying a RACF JWT, how long that takes. So finally on this section is something about a new feature of the Z14 called Instruction Execution Protection. It provides the ability to separate out program and data storage. Code can, when configured, code can only run on executable storage and not on data storage. The purpose of this is to prevent buffer overflow type of problems where code is hidden in a data area. Then some bad actor, which requires an insider to call it, some bad actor calls this code, and you can inject by this mechanism bad code onto a ZOS system. Exactly how you do this, I won't go into. I'll leave that as an exercise for the reader. But here gives sort of an example. You've got executable storage at the top there, protected storage, but instead of the protected storage being data, on the right-hand side, you can see, those of you that can read assembler, there is a whole series of assembler instructions that potentially could be bad and affect the system in some way. So in the Z14, there was the capability to separate out data from program and prevent execution on non-executable storage. And this requires either 2.4 ZOS or 2.3 plus some APARs. From the ZOS point of view, the externals is a new option on the storage command or the get store command to specify executable equals yes or no, or in the case of the 64-bit storage, system rules, which is a way of defining what your system will use as default. It's not available on the get main command. Now, customer applications, CICS applications don't use in the main get mains or storage commands. They use CICS storage. So what you'll see here on the left-hand side is the way that CICS manages that storage. It stores it, it manages it in things called DSAs. Now, each DSA has a purpose and a storage key associated with it. So we've got the RDSA and ERDSA for reentrant programs, the SDSA for shared user key programs, and also user key storage, and also user key programs. CDSA for the CICS storage, and also CICS key programs, and the UDSA for CICS storage. Now, in order to implement the instruction execution protection, we had to create two new DSAs for the purpose of separating out the storage from the programs for the CDSA and the SDSA. So there are two new DSAs, which are the PUDSA and the PCDSA. And those are for user key and CICS key programs. All the pink areas that you've got there, if you've got the storage protection switch on, are the program storage, and all the green areas are the data storage, which you can't execute programs in. So what happens if you do try to execute a program or execute some code in one of those green areas? Well, you'll get an event, an OC4, which we will trap in the eStay and produce an error code where you can simply identify that it's as a result of storage execution. And you've got all the usual information of in the PSW and the bear associated with that event. Now, it might be the case that you actually do need to execute code in data storage. It's probably not a good reason why you might do it. There may be some code really from some very old program, but you don't want to change that. So we're providing a number of interfaces so that if you really do want to get executable data storage, you can do. So all the various get main options are supported, and also the ways with glues and trues and assembler programs where you need something in your stack, in the data that's passed to it in the work areas, you can specify that you want executable storage. In order to use these options, you've got to have the CICS EIB specified. And the reason for that is it's really only intended for ISVs rather than customers. We know that a number of ISVs and indeed other IBM programs do make use of executable code in data storage. We're making changes to stop that in our code, and we need to encourage vendors to do the same thing. But where it's not possible, then this is the way around it. But we don't want to encourage too much of it because that destroys the purpose of the item, which is to prevent buffer overflows and the attack vector of inserting code into CICS and MVS. Now, it's not intended in the open beta release immediately for people to switch this on in production when that eventually becomes a release. It is something that it's there in order for ISVs and also customers to test whether they've got any code which is in data storage. And because of that, this is feature toggled on via those two feature toggles. So what we would, what we'd recommend both to ISVs and customers is to try this out to see whether they've got a problem, see how big the problem is, and it will be necessary either not to have this on and accept the risk, although that may not be a long-term solution, or alternatively try and work out a strategy for removing that code or requesting vendors to remove that executable code. And finally, I've got a section here which is on simplification that we are doing and improved diagnostics. Both of these are in the open beta. Now, messages that you will probably all be familiar with are the security messages where you've got an authorization failure. These are the XS 1111 messages and also the associated ICH 408I from RACF or whatever is the equivalent for Broadcom customers. These were designed in the days of 3270 screens and single systems or small numbers of systems, and were at that stage very easy to diagnose. But there is more of a problem nowadays because things are really multi-region. A lot of use is made of web services and other request APIs coming in over functional user IDs, and transactions can be routed all over the place, often automated, so you don't know where requests are going to. And the problem is, how do you identify the end user? Obviously, you can see what something needs authority for, but you don't just want to grant authority. You need to know a lot more information about it. And we've done a lot of interviews with customers, finding out what the security problems they've got. And this sort of problem can take a lot of time trying to find out who the real end user was. You may need to take traces across the system in order to do this. And that can be difficult because you don't know what system some requests are being routed to. You may need even to take dumps of systems or work with our level 2 support organization to try and find out what the actual problem is. So what we've done is we've introduced a new security message to accompany the XS 1111 message. We didn't want to change the 1111 message because it's so used in automation. So we've got an accompanying 1117 message that goes alongside each of the 1111 messages. And in these, you'll get a lot more information about the origin data of the original request. So I've given two examples here. You've got an example from a web request, which is routed across from one region to another. And you will see information there about the IP address and the port, and importantly here, the TCP/IP service that the request came through. And lots of other information, including where the request came from, what was the original Apple ID the request came from. So that information should be sufficient to diagnose who the end user was. And another example, in this case, a terminal application going from a TOR to an AOR. You've got all the information in the message which occurred on the AOR of what the TOR client was. So that, again, will give you the information about who the real user was. Because it may be the case that it's a different user ID. It may be just the link user that has failed, and you'll be able to find out the end user. If you're using distributed identity, in particular, obviously, for web requests or web service requests, that will also be available in the message. So you'll be able to find not just the functional user ID, you'll be able to find the end client. As we were talking to a lot of customers about what their security problems were, what was time consuming, something that occurred in many customers, which I was rather surprised about, was the problem in setting up category 1 definitions for regions. I thought this was sort of a one-off activity, but obviously when you add a region, and also when you upgrade from one release to another, the category 1 transactions change from one release to another. And all category 1 transactions, the security definitions associated with category 1 transactions, the purpose of those is to ensure that only region user IDs are allowed to access those transactions. If you misconfigure it, it means end users could use category 1 transactions, which may have detrimental results on the CICS region they're typing on. Now, there are complications in setting things up. One, because we add periodically category 1 transactions and people forget to upgrade their security definitions when they do an upgrade. Another is the complication of sec prefix. So adding new regions can cause a problem there. And it also means if we try and add a category 1 transaction in service, there is a lot of difficulty with that in making sure that customers upgrade things before they install the APAR with the change-ins. So we try and avoid, have tried in the past to avoid ever adding a category 1 transaction in service. Now, something that when thinking about this, after customers explained how much time it took them, had to think of what were the security definitions doing in the first place? Because we're asking the security manager, can the CICS region ID access this transaction? Because CICS knows the region user ID, obviously, we know who we are. We know the list of category 1 transactions, there's a list inside the program, and we know how the transaction started because they can't be started from a terminal. So why are we asking the ESM when we know all the information ourselves? It's not really a security check. So we've actually removed in the open beta the need for category 1 transactions. We make the check internally within CICS. And by doing this, we've actually made it more secure because it's not possible to misconfigure things anymore because we've got all the information ourselves. And so we can do the security check internally. So what happens if somebody does type or try to start in some way, however it is, a category 1 transaction? Well, we'll append the request. If it's not kickstarting it in the way that it should start it, it will fail with an AXS1 append. As a consequence, we've removed also the category 1C list. Now, we've spoken to a number of auditors as well as part of our research work. And one of the things auditors look for are, have you secured your category 1 transactions, on the grounds that that's an easy thing for an auditor to check. So we've made it very clear and added a new auditor section in the CICS documentation, or really made it much clearer where the auditor section is, and specified that auditors do not need to do this anymore because CICS is secure, and explain about why it's secure without the need for these security definitions. So that was a bit of a whistle-stop tour of all the changes. As you can see, the fact that it took 50 minutes explaining that there's a lot of enhancements in the 5.6 and also in the open beta. I've given some references which are the open beta documentation. Also, the open beta was announced 4 days ago, and that's a link to the announcement with all the other features as well as the security features. If you've got any feedback on the open beta, you can do that in the documentation as well as in the community. And also, if there are enhancements that are not here in the open beta that you would like, then I'd very much recommend you go to this site to request the enhancements. Something I did on a previous security presentation a few years ago was do a lookup of how many RFEs, customer requirements, we've implemented recently, because we always got a comment from many customers saying, oh, there's no point in raising a requirement because you never address it. We've actually addressed 620 separate customer requirements in CICS version 5. And that's the number of separate requirements. Many of those requirements have been voted for multiple times by different customers. And we always will lean towards implementing new changes which are voted for with that multiple customers are interested in. And it's important really to get that information raised so that we can discuss with you any use cases that relate to the requirements, rather than just guessing what we should implement. So there's a plug there for raising new requirements. So that's all I've got. So if there's any questions.
Yeah, if I can jump in, there's a chat section on Zoom. So if you want to type questions into the chat, then we can get.
Let me try and find it. I think I'll have to stop sharing. Do I have to, where do I get to chat? Oh, right. Okay, chat.
Yeah. Oops.
Is there a place where we can see a list of the 620 RFEs? If you go to that website, I believe you can list all of the RFEs. So it's not just raising them, but you can also list them. Is that the only question, or have I?
No, that's the only one that's come up so far, but
okay.
Let's pause a while just in case there's more.
Apologies for rushing through that, but as I say, there's quite a lot of information on there. More details in the documentation for the open beta. And also, if you've got any feedback, especially from your newer system programmers about the new security documentation, we would really appreciate that.
Yeah, you could just got a new question then.
Yeah, is CICS going to enhance the health checker with more performance or storage information in the future? It is something, it's not really designed so much for performance information, because it's all to do with configuration. The tooling that we already provide is really the information, things like a Megamon or performance or PA are the places where you would specify performance information. But it is something that configuration information is something that is being thought about. What we're looking for are sort of examples with customer RFEs about more specifics of the sorts of things they would like in terms of the health checker. Currently, the only things that we've got in the near future are checks on security, but it has been discussed. But yeah, waiting for RFEs really to get more concrete cases and also a dialogue with customers who feel that would be useful. Okay. And in terms of the storage on there, I direct your attention to something that I briefly mentioned, which was in 5.6, we introduced a new short-on storage mechanism, new storage monitoring mechanism for ZOS storage, because we've had the short-on storage mechanism for CICS managed storage for a long time. But obviously, we'd appreciate that there is ZOS storage as part of the address space, which is being used, for example, by Java, also by RACF. And we had experienced a number of cases where a request, such as a security request, got some 24-bit storage and caused the region to come down because it ran out of 24-bit storage. So we put in a new mechanism to monitor that and issue alerts when you're getting close to the storage, and also stall requests when you get too close to the running out of storage.
Okay, if anyone else has got any questions, can you type them in now? Otherwise, we will move on. Let's give you a second or two to do that. Okay, well, I'll start to move on then. So, Colin, can I thank you very much for that presentation? Loads of information in there. That was brilliant. And because we're a virtual user group, can you assume that you're getting a virtual round of applause at the moment?
Thank you very much. I'll clap myself here.
All right, thanks. Yeah, I'll go back to sharing my screen then. I've got a couple of slides to go through. So news, well, slightly old news, but IBM has announced COBOL for Linux on x86 1.1, bringing IBM's COBOL compilation technologies and capabilities to the Linux on x86 environments. COBOL for Linux on x86 supports the integrated CICS translator to handle native COBOL and embedded CICS statements in a CICS COBOL application. This enables COBOL batch applications to access vSAM emulated files stored in DB2 and CICS TX SFS. COBOL for Linux on x86 in conjunction with IBM TX series for multi-platforms and compatible with IBM Enterprise COBOL for ZOS and IBM CICS Transaction Server for ZOS. There is a link to that story on our website. Yeah, articles and blogs. I'm not sure whether we've had this one, but the CICS command level translator by Darren Beard and Andy Wright was in Enterprise Tech Journal issue 2. And again, the link to that will be on our website. So, as always, can I ask for feedback about this meeting? You can comment on anything good and anything you think we can improve on for next time. And again, you can email your comments to me. My address is on screen, or you can use the Contact Us webpage. And in fact, if you've got any questions for Colin, if you send them to me, I'll pass them on. So, coming soon, on the 14th of September, we've got Colin Pierce, and he'll be discussing collecting and analysing CICS statistics. And then the last meeting of the year for this group is 16th of November, and we've got Ezreal Gross, who's now Principal Solutions Advisor, IBM Systems CICS at Rocket Software. And he hasn't finalised what he wants to talk about, but I'm sure it'll be interesting as always. So that's it for this meet. Oh no, sorry, forgot about social media. Yeah, we're on Facebook, we've got a page, we're on Twitter, there's a group on LinkedIn. LinkedIn doesn't do vanity URLs, so it's an incredibly long one, but the links to all these are on our website. And if you do tweet or Insta or any of those things, the hashtag to use about us is hashtag virtual CICS. Okay, so that's it for this meeting of the Virtual CICS user group. Can I thank you all for attending? Thanks to HostBridge Technology, the people who sponsor our user group and make these meetings possible. And of course, I'd particularly like to thank Colin Penfold for his presentation. So that's it. Thank you all very much for joining the meeting. And I look forward to seeing you all on the 14th of September.